Space exploration. The possibilities for discovery are limitless. A tremendous amount of knowledge has been gained since the dawn of solar system exploration, sparking new questions and a quest to learn how did we get here and where are we destined to go. In NASA's Discovery program, scientists venture deep into their imaginations, finding innovative ways to unlock the mysteries of our solar system by answering some of humanity's oldest questions. How did the planetary bodies of our solar system and cosmic structures beyond our solar system form and evolve? Has life evolved elsewhere in the solar system, or are we alone?
Hi, I'm Michael New, the Discovery Program scientist. The Discovery Program is an innovation developed by NASA in 1992 as a means of harnessing the creative energies of America's scientists and engineers to enhance our understanding of our solar system through a series of focused, frequent deep space missions. This innovation has proven so successful that Discovery missions are now considered an integral part of NASA's strategy for exploring our solar system. Discovery missions are selected through an intense competition involving extensive peer reviews of scientific, engineering, management, and cost aspects of proposed missions. These proposals originate as the idea in the mind of a single scientist, whom we call the principal investigator, who assembles a team of other scientists, engineers, and other experts to prepare these highly detailed proposals that cover all aspects of a mission from its start to its finish. NASA holds the principal investigator ultimately responsible for both the scientific and technical success or failure of his or her mission. Data and samples returned to Earth by Discovery missions are a vital resource for future generations. As new analysis techniques are developed, these data are continually reinvestigated, yielding new scientific discoveries. Anyone with an internet connection can access data brought back to Earth by Discovery missions. Because samples brought back to Earth from deep space are so precious, access to them is more strictly controlled. The results of completed Discovery missions enhance our scientific understanding of the origin and evolution of our solar system, the potential for life elsewhere, and the hazards and resources humans will encounter as we move off our planet of origin and out into space. Findings also lead to new scientific questions, ones we never would have thought of before, which in turn inspire new mission ideas. In order to carry out these new missions, NASA will need new generations of scientists and engineers. The Discovery Program is one of NASA's first to require that its missions have a comprehensive education and public outreach plans to bring the thrill of discovery and the excitement of science to students of all ages and the rest of the American public. Hands-on experiences are especially encouraged in order to bring science to life for Americans everywhere.
10 Discovery missions have been selected since the program's inception in 1992. Half of the missions study unique aspects of small primitive asteroids and comets. 2 explore planets. 1 traveled to the moon. 1 collected atoms of solar wind. And 1 will search for Earth-sized planets around other stars. Each Discovery mission adds another piece of knowledge to help solve our cosmic puzzle. Discovery's first mission to depart Earth, the Near-Earth Asteroid Rendezvous, or NEAR, later named NEAR-Shoemaker, honoring planetary pioneer Gene Shoemaker, was destined for Eros, the second largest of the near-Earth asteroids. The 4-year, 2 billion-mile journey to Eros took NEAR through the inner solar system and passed the main belt asteroid Matilda in 1997 for a first close-up look at a C-type carbon-rich asteroid, before successfully going into orbit around the 20-mile-long stony S-type asteroid Eros. Eros became a celestial laboratory for scientists to answer many fundamental questions about the nature and origin of asteroids, a primary mission goal. Each of NEAR Shoemaker's 6 science experiments contributed in different ways to understanding the structure and composition of Eros. After returning more than 160,000 images and achieving all of the planned science goals, the mission team programmed NEAR Shoemaker to descend and land on the surface of Eros to obtain unique measurements of surface composition. The spacecraft was not designed to be a lander. The highly risky yet carefully planned maneuver successfully set the spacecraft down on Eros near Himeros, the asteroid's prominent saddle-shaped depression. Instrument data from this first long-term study of an asteroid have revealed Eros to be a cracked yet mechanically coherent rock with a density similar to that of Earth's crust. Scientists now believe that Eros formed as a chip off a larger asteroidal body. Up close, Eros revealed a truly unique and geologically active landscape, with many craters altered by mass motions of loose dust and debris, called regolith, that in some areas is thought to be as deep as a 10-story building. Much of the surface is strewn with millions of boulders, some the size of a house. The Erosian geology is a complex mix of craters, grooves, and ridges, as well as exceptionally flat, smooth areas of fine regolith called ponds, which were not expected. Near's new and surprising details about asteroids are enticing scientists to seek what processes determine the surface geologies and internal structures of asteroids, and how do they depend on asteroid size. Perhaps Dawn, Discovery's next asteroid mission, will unlock some of these mysteries. A journey in both space and time is planned for Dawn, NASA's first truly interplanetary spaceship. Dawn's expedition includes extended stays at 2 celestial bodies, something no other spacecraft has yet been able to do. Dawn will travel to the debris-strewn, ring-shaped asteroid belt between Mars and Jupiter. There it will conduct a detailed, close-in study of Vesta and Ceres, 2 of the earliest discovered and most massive asteroids in our solar system. Studying these 2 very diverse minor planets with the same set of instruments will give scientists a snapshot of conditions during the first 10 million years after the genesis of our solar system. Among the goals of Dawn are to determine the shape, size, surface composition, internal structure, and chemistry of Vesta and Ceres, and to better understand the role of size and water in planetary evolution. Dawn is the first Discovery mission powered by ion propulsion, an advanced technology that allows it to carry enough fuel and adjust its velocity to orbit and study 2 asteroids during one mission. After traveling 1.9 billion miles through the inner solar system, Dawn begins 7 months of intensive study at Vesta in September 2011. Then it races 1 billion miles farther and arrives at Ceres 3 years later.